So for our last example here, we are looking at the HIV virus, which is known to infect and kill the body's T cells. T cells help stimulate the immune system, so their destruction makes it so the body cannot defend itself against other pathogens. It's why people with AIDS tend not to die of AIDS directly, but instead of other infections like pneumonia. So the progression of HIV without medication can be monitored by the average amount of active T cells in the body, as graphed below, where F is a function of the number of T cells X years after infection. Why would this be a function? And find and interpret the value f of 8. Well, at least we're going to estimate f of 8. So this is a little bit more serious than some of the other examples I'd say that we've done, but here the reason why this is a function is because at any one time your body can only possibly have one amount of healthy T cells. You only have that number there at that specific time. It doesn't change in any way. It is that constant sloping functional value. Meanwhile, if you want to get the value for f of 8, looking at that graph, it's not necessarily the very cleanest picture, but we can probably estimate there that f of 8 is something like 200, where with that picture in mind, it's actually important to note that when the body is seen to have 200 healthy T cells, let's see, what is the exact unit there, per milliliter of blood, to be sure, is when an AIDS diagnosis is officially given. So that's what we get from that specific value there, that after 8 years, if you're not medicated, on average, you are likely to be diagnosed with AIDS. And that's all we're going to get here for section 2.1. Next, we're going to move on into 2.2 and so on. We're going to actually look at some more special kinds of functions in particular.